IR spectroscopy or infrared spectroscopy. Infrared spectrum is an important record which gives sufficient information about the structure of a compound. Unlike ultraviolet spectrum, which comprises of relatively few peaks, this technique provides a spectrum containing a large number of absorption bands from which a wealth of information can be derived about the structures of an organic compound. The absorption of infrared radiation causes the various bands in a molecule to stretch and bend with respect to one another. The most important region for an organic chemist is 2.5 micron to 15 micron, in which molecular vibrations can be detected and measured in an infrared spectrum and in a Raman spectrum. The ordinary infrared region extends from 2.5 micron to 15 micron. The region from 15 micron to 200 micron is called far infrared region, and that from zero point 0.8 to 2.5 micron is known as, or it lies in near infrared region. The absorption of infrared radiations can be expressed either in terms of wavelength or in wave number. Mostly the infrared spectra of organic compounds are plotted as percentage transmittance against wave number. The relationship between wavelength and wave number is as follows. That is, wave number is 1 upon wavelength in centimeters, when wavelength is taken in centimeters. Molecular vibrations. Absorption in the infrared region is due to the changes in the vibrational and rotational levels. When radiations with frequency range less than 100 per centimeter are absorbed, the molecular rotation takes place in the substance. As this absorption is quantized, discrete lines are formed in the spectrum. Due to the molecular rotation, molecular vibrations are set in, which are more energetic radiation in the region 104 to 102 per centimeter is passed through the sample of the substance. The absorption causing molecular vibration is also quantized. Clearly, a single vibrational energy changes is accompanied by a large number of rotational energy changes. Thus, the vibrational spectra appear as vibrational rotational bonds. Fundamental vibrations are classified as: first, stretching. In this type of vibration, the distance between the two atoms increases, that is, or decreases, but the atoms remain in the same bond axis. Here it is shown this type of vibration is stretching, and bending is this type, when this move closer or far from each other. The this type of vibration, the position of the atom changes with respect to the original bond axis. We know that more energy is required to stretch a spring than that required to bend it. Thus, we can say that the stretching absorption of a bond appears at a higher frequency, or we can say as higher energy as compared to that of bending of the same bond. The various stretching and bending vibrations of bond occurs at certain quantized frequencies. When infrared radiation is passed through the substance, energy is absorbed and the amplitude of that vibration increases. From the excited state, the molecule returns to the ground state by the release of extra energy by rotational, collision, or translational processes. As a result, the temperature of the sample under investigation increases. Now, Here the types of stretching: symmetric and asymmetric. Symmetric when move together. Here when the stretching is opposite to each other. Types of stretching vibrations are of two types. Stretching vibration, first is symmetric. In this type, the movement of the atoms with respect to the particular atom in a molecule is in the same direction as shown here, when both move outwards or both move inwards. Here one is moving outwards and one is moving inwards. The asymmetric stretching, in this vibration, one atom approaches the central atom while the other departs from it. Now, type of bending vibrations. Bending vibrations are of four types. First is scissoring. In this type, the two atoms approach each other. Second is rocking. In this type, the movement of the atom takes place in the same direction. Wagging, the two atoms move up and below the plane with respect to the central atom. Twisting, in this type of atom, the atoms move up the plane which the other moves down the plane with respect to the central atoms. Here we can see in the figure the type of vibration. First is scissoring. Here we can say this is the central atom and they are moving just like a scissors. या कैंची की तरह ये दूर और पास जाते हैं. Rocking, this type of vibration, this is the central atom and they move in this direction. Wagging, here this is the wagging when the two moves up and below the plane with respect to the central atom. That is, ये बीच में है, ये ऊपर और नीचे इसके रिस्पेक्ट में जाते हैं. और ट्विस्टिंग ये है कि एक नीचे जाता है और एक ऊपर की तरफ आता है, इसको अपन ट्विस्टिंग कहते हैं. दिस इज द टाइप ऑफ बेंडिंग वाइब्रेशन, सिजरिंग, रॉकिंग, वैगिंग एंड ट्विस्टिंग.